Again, good morning, grade 4. Hope you are all fine and doing well, as always. And we'll
We
just
hope
have a
you
quick
find food.
over what we studied about in last time. It was static electricity, and you guys did amazing things. You just kept rubbing things against your head and seeing if it attracts or not. So today we are going to just do a quick review over it. So static electricity is not moving electricity. It just builds up on an object. Okay. So can you see this comb, for example? We use it to brush our hair, to comb our hair, right? Yes. Can you see these blue lines over it? Can you guys see it?
Yes.
Yes, those are
Yes,
charges. Those are electric charges forming over it.
Yes.
So when I keep rubbing it against my head, the comb starts gaining electric charge or negative charge to be specific. And this charge building up on the comb is what we call static electricity. Static actually means not moving, like standing still. So as I keep brushing it or moving it through my hair, it gains electricity, but in a negative charge. Okay. So it's the same what happened with when you guys started rubbing things against your head last time, and how the pieces of the paper got attached to it. And because we can have different charges, positive and negative charges. Do you know the positive are the one that are attracted to the negative, and negative actually get attracted to the positive because they are different charges, different electric charges. Okay. So this is what you guys did last time. You can actually try it with plastic comb. Brush your hair and then attach some small paper to it, and you'll see how the paper will stick to the comb. Okay. Just let me move a little bit through this because we don't need it. Okay. Do you know that we have this device in school? I hope that we can use it. This device actually creates static electricity. So what happens that once we touch it here, let me
your hair is up.
show it how to you guys how it works. So tap different charges in here, and as the charges move or rub against this big metallic or I'm sorry, plastic ball, the charges start building up. Can you see some positive charges up there? Positive? Can you see the positive charges over its surface?
Yes.
Yes. Once you come and touch it,
Yes,
or you bring something else with different charge, you can see some light going on. Or if you touch it with your hands, your hair will actually stand up. You have a picture in your textbook with a girl with her hair sticking up because she's also touching this device. Okay. So that was what we said or talked about as static electricity. So again, static electricity is standing still, it's not moving. We have another type of electricity, which we call the current electricity. And current is actually the moving electricity through wires, the one we have in homes. Okay? Are you guys still hear me? Do you guys still hear me?
yes,
Yes.
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 So again, do you think we can
yes.
use static electricity for I don't know, lighting a lamp?
No.
Yes, it will be
No,
so weak. It will be so weak. It will not be so
no.
powerful.
Miss,
So
because
that's
it has
why we
no
need
high voltage.
yes.
It has no high voltage.
Yes, it doesn't have high voltage and voltage, and we need it so we can, work devices in homes and light bulbs and stuff like that. So, what do you mean by current electricity? It's the electricity that moves through wires, moves through wires.
Wires.
Okay, yes, the one that we have in our homes. That's why we call it current electricity. Okay. And in order for the electricity to move through the wire, we need to build what we call a circuit. Here is the word for a circuit so you guys can see it. A circuit. Can you see this?
Yes.
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 So,
Yes,
what is a circuit? We can say that a simple circuit is just made up of wire, a bulb, and a source of electricity. We can say a battery or something. So, just to make the electricity work. or move through the wires. And we need switch to be in control of this circuit. So if we wanted to say a simple circuit, these are the things you guys need to use. So we need a bulb, a light bulb. Can you guys see it?
Yes.
Yes. We also need a battery,
Okay.
okay, to complete it. And we need a wire and maybe a buzzer just to make sure that we know that there is electricity or not. Okay. Each one has a symbol. Just let me get it for you guys from here. Can you guys see my screen now?
Yes.
Okay.
Yes.
So again, as
Yes.
we talked before about static electricity, so it happens normally when we actually wear a wool shirts, like shirts made up of wool, we can actually feel the static electricity in our hair. So again, static electricity can cause a lot of things like lightning. Lightning that happens during thunderstorm is actually caused by static electricity. What happens is that two waves start rubbing against each other, and then they start gaining negative charges, and then the lightning starts moving from the clouds up to the earth. We can actually feel static electricity sometimes when we touch metallic door knobs. Do you know that? We can actually feel that sometimes,
Yes.
as if electricity just moves through our bodies. We get just a small shock, like, oh my god, was that electricity? It wasn't real electricity, like not really strong one. It's still electricity, but it's called static electricity. Lightning is one of the things that can be caused by static electricity too. Okay.
Okay.
Okay. So here is Benjamin Franklin. He was the one that did an experience about lightning. You guys don't have to learn about him, but just let's review some of his information. So he was interested in negative and positive charges, or in static electricity in normal, and he wanted to study about lightning. So as you guys can see, he had a kite. Can you see the kite up in the sky?
Yes.
And he
Yes,
meant
he bought a
to
string.
fly it during a thunderstorm. So there was a thunder cloud up there. Can you see a really thick cloud in the sky? Can you guys see it?
Yeah. Yeah.
Yeah, so this cloud is so thick. Now he knows that maybe there is a high chance of lightning. Okay, so he just flew his kite, and he just put a key at the end of the.
So we have to study this too?
No, I'm just telling you guys the story how he
Oh,
discovered
the
it.
kite was he bought made a out string. Of silk. Miss, he bought a string
The
and
kite.
then he tied the key at top of it, and then at top of the key he tied the kite.
Yes, I believe you can see now what happened.
Miss,
Okay,
yes.
yes.
We took this term a story about Benjamin Franklin about this.
Oh, so
Yes.
now you know what
It's
happened.
okay.
That's
Yeah.
nice.
This is how do we know? Talk about him, but I thought I was like I think it isn't him.
Well, anyway, can you guys see what happened? It's okay if you talk about him before. You don't have to study about him, but just it's nice to know more things, more information in life. It's nice to learn new things. So can you see what happened to his hair? The picture
It flew away.
just straight up because it has some static electricity going through it because he touched the
Exactly.
key. Okay, but can you see how the lightning also hit the tree? Can you see that? How the lightning hit the tree?
Yes.
Yes, I see it.
Yes. That's why they say during thunderstorms or heavy rain or If there is lightning and thunder, do not stand under a tree. Do you know that? This is really important. Don't ever stand under a tree during thunderstorms or rainy storms, because lightning is actually attracted to trees, and that can cause death to some people because lightning is so strong and it has really, really strong strike that can kill some people. So this is how he proved his idea that lightning is also caused by static electricity. So let me move to the next part. Okay. We just learned about this, how static electricity builds up when I rub against something plastic. Charges are built up on this object and starts attracting things that are made up of the opposite charge. Now let's get back to the current electricity as we were talking about it right now. And we said the big difference between current electricity and static electricity is that current electricity needs wire to move through it, needs wire to move through it, okay? And that's why we need to build a circuit for the electricity to move through. In order to build a circuit, we need a wire, we need pulp, we need battery. Can you guys still hear me?
Yes.
Yes, so we
Yes.
need the battery because it's the source of electricity, so we need it. And we need the wire for the electricity to move through it. But because it's sometimes hard for me to draw a pulp every time and draw a real battery every time, so we use instead some symbols that makes it way easier for us to draw a circuit. Okay? Are you guys interested to learn these symbols?
Yes.
Okay. So here we have, just let me close things
Miss,
like
I
that.
took the symbols, but I forgot them
It's okay.
because in grade 3 I used to go to a lesson
Mhm.
and I talk about electricity.
Electricity, yes. It's actually interesting learning about electricity. So we can represent them with different symbols. Let me draw it for you guys here. So the battery, for example, can be made up of two lines, one big line like this, one big line like this, and one small line next to it. So this is the battery. Can you guys see how it looks? We can represent it with this simple. A wire is just a straight, simple line. A bulb, we can represent it with different shapes, but one of the most famous shape is a circle with an X inside of it. Oh, okay. Let me. Oh, I can't draw it the same way. I have to draw the X first. Okay, and then the circle around it. So here is how a bulb can be represented. Can you guys see? This is how a bulb will look like if I want to draw a simple circuit with two lines at the sides. Simple, right? It's better than drawing a whole real bulb. And buzzer is not actually, you guys don't have to use it. So yeah, we have those three main parts. So if I wanted to draw a simple circuit, I would draw these symbols. Can you see them? I need you to memorize them, okay?
Okay.
Okay, so now let's move out. I have these battery things still up there, so let me clear all of them. Okay, so if you guys can see, I'm going to show you a simple circuit and you can tell me the different parts, okay? Okay?
Okay.
So we
Okay.
have this part first, this part, two lines, the one I'm highlighting. What do you guys think this is? What does
Battery,
this
battery.
symbol represent? Battery, yes. You can see the positive part. You know, the battery has two sides, positive and negative.
Negative.
Yeah, so we have positive and negative on the other side. Okay. What does
Okay.
this circle with an X represents?
May I say
Yes, you can say it.
it's a bulb?
It's a bulb. Yes. Yusuf and Muhammad, you guys are raising your hands. Do you need anything?
Miss, at the battery, you said one side is negative and one side is positive.
Yes.
Do you know when you get a battery, you make in the negative part, like you make a plus and minus. The one who made put them.
Yes, he shows you with instructions. Yes, he draws a
Yeah.
negative boards. Yes, he does that. So you can know which part you should put it, which part you should put it, for example, in remote controls. What kind of parts should you use?
Yes.
Yusuf, you raised your hand. Did you need anything? Yusuf?
No, no, I don't. I just forgot to lower my hand.
Okay. So the X with a circle is actually presenting like what Rugmini said. It's a bulb. Can you see the line connecting all of those together?
Wire, it's wire. It's wire.
Wire, yes. So this is just what we call a simple series circuit. Why is it called series circuit? Because everything is next to the other. What does that happen? And what does that mean? So if I wanted to draw how the bat or the electricity will move through the circuit, I would say it will move through the wires. Can you see the red arrow? It's showing you the electricity moving through the wire. Can you guys see it? Can you see it?
Yes, yes,
Yes.
yes.
So here's the electricity moving. I'm sorry, let me get back to this because it's supposed to move from the negative to the positive. Let me get this down there. You guys can see the full screen. Yeah. So the electricity again, or the electric charges, they move from the negative part up to the positive part. So here's it moving through the circuit, first through wires and then through the bulb. And this will cause the bulbs to light up. And then it will continue till it reaches the positive part. Can you guys see that?
Yeah.
Yes. Let me accept your friends. We have some people in the waiting room. Okay. But what happens if I'm having a gap or a space in the wires? For example, let me draw it to you, show it to you here. Yes. What if I'm having a gap in here? Just let's use it in a white color. What if I'm having a gap in here? Can you guys see it?
Yes.
It will
Will
stop
the electricity
working.
keep on
It will
moving
stop
through the
the
wires?
electricity. Working. It
It
will
will
stop
stop.
the electricity.
Well done. It will stop
The
the electricity.
electricity will stop flowing.
Will turn off. Yes, all the bulbs will turn off. So that's what we call a series circuit because all of them are connected in the same thing. Like the electricity have only one path to move through. So if this path was broken or there is a gap of air between the wires or the wires are not connected well or one of the bulbs actually broke down, that means it has a gap in here. So it will also cause the circuit to not work. So this is what we call a series circuit. So what is a series circuit again? It's happened when everything is connected in the same path. Okay? Like it only has one path for it to move through. Okay? Can you guys see it?
Yes.
Yes. So
Yes.
let's see now. Let's get out of this slide and see what happens if we change this circuit into another type. Okay, let me get out from this form. Okay, why isn't it working? So can you guys see that in series circuit, the simple circuit, everything is connected in one loop. Can you see that? One loop. Like if one part of the circuit is broken down, all the circuit will break down, right? Everything will shut down.
Yeah.
Do you guys think we can use things like that or a circuit like this in home? Guys, can you hear me?
Yes.
Yes.
Yes, I'm having some noises from some people. I'm gonna mute you guys all. So, okay, now I can hear you well. So, do you guys think that we can use this circuit in homes, like in lighting the bulbs and turning on devices and using the TV,
No.
computers, the Wi-Fi, everything? Do you think we should use a circuit like this?
No.
Yes, no, well done.
No.
Because if we use a
No.
circuit like this, if one bulb in the home just broke down suddenly, everything will break down, right? Everything will shut down because the electricity
Yeah.
now will have only one path to move through. So that leads us to the next type of the circuits. Okay, so in here he's showing you the current moving through series circuit and how everything is connected in the same path. But then I want to show you now the other type of circuit, which is the parallel circuit. Okay, so we have another symbol for the light bulb. It could be a circle with a half circle inside of it, or an X, as you guys just learned. So, in those circuits in front of you, which light bulbs will light? Which one? Can someone tell me? Raise your hands, please. Okay. Okay, we have three people raising their hands. Um. Okay, Wahba.
B.
B is the one that's going to work, right?
Yes.
Yes. Do you guys think the same thing?
Yes.
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 Okay, that's nice. Well done, everyone. So yes, it's gonna be B. Why B, Wahba? Why do you think it's B, not C, D, or A?
Because there's no gap in the circuit, and because the light bulb isn't like out. It's not working.
Yeah, so we don't have any gaps. That's right. Everything is connected by the wire in B. Yes, well done. So that means it's gonna work perfectly. But in A, C, and D, we have gaps. Like they are not even connected by a wire. Well done. Thank you so much. Now, this is a complete circuit. And here
Okay.
we have another shape or another sample that we added to the circuit. Can you guys see it?
Yes.
Yes.
Okay, so as you
Okay.
guys can see, we have a new sample that we added. Can you see this one? I'm doing circles over it. Can you see this one on the left of the battery?
Yes.
Yes.
Yes. This is a switch. And why do we need a switch in the circuit? What do you guys think we need
To
switch?
light up the light bulb,
What?
to light up the
To
like
control,
electricity in the
yes,
light
to
bulb.
light up the light bulb, yes, and it's to control the circuit. So if I had all
Yes.
the
Yes.
wires connected, that means I cannot control the circuit unless I cut the wire, for example. But if I'm having a switch, the switch is also giving me the control. Like I can control it now. If I turn it on the switch, it will work. So here we have all the electricity moving through the wire, as you guys can see. and the light bulb is yellow, which means it's working. Okay, can you
Okay.
guys see that?
Yes.
Yes, once I turn it off or closed the circuit or turn it off I'm sorry, turn it on the switch. So when I say turn on the switch, that means electricity is on. When I say turn off the switch, that means it means electricity is off. Okay. We use in here the red arrows are showing you guys what we call electric current. And this is what moves through the wires. Electricity moving through the wires is called electric current. Can you see it down there?
Yes.
Yes. Here we have another simple circuit. Can you guys see it? With two lamps or two bulbs and a source of electricity. Do you mean what do you
Yes.
mean by electric by battery? You mean is that what you mean? What do you mean by the term battery? Is that what you meant by your question?
May I answer?
Yes,
It's the source of electricity.
it's the source of electricity. Yes, but that wasn't your question. That wasn't your question, right? Okay, you can send your question again because I think there is a problem with the internet and I really cannot hear you now, right now, unfortunately. Okay, now we have this I'm sorry, this circuit up there. Can you guys see it? This circuit up there. Circuit A, can you see it?
Yes.
Yes. So in circuit A, if I wanted to show you guys how the electricity will move through the wires, I would draw again an arrow. Okay. And I will start with the battery with the negative part. So can you guys see the arrows moving? The arrow shows
Yes.
electricity. So when I come to this point, now the electricity have two paths to move through.
Other
Can
path.
move this way and also this way, right? So as it moves
Yes.
this way, it's lighting up the first bulb, and then as it moves in this way, it's still lighting up the other bulb. Okay, I wasn't supposed to use a white color. Let me change it. Can you see? Okay.
Yes.
And now they will both collect in here and keep on moving, both electricity, until they reach the positive part, and both bulbs will be working. Now, I
Yes.
want you guys to imagine if one of the bulbs went down or was broken down. This one down there, it was broken down. Okay.
The other one will be like still
Here it
light
is.
up.
The
Huh.
other one will work.
What do you think will happen?
Mhm.
Yes, the other one will
The
keep on
other
The
lighting
will
or
other light
will break
bulb will
down.
be
yes
like, yeah,
Will it break
will
the
down?
keep lightning. Will keep
it will
lightning.
keep
Keeps lightning
it will keep
because
light.
electricity is still having a path to move through. But if on B, on circuit B, if one breaks down, what happens?
It will stop.
Both of them stop. Yes, well done. So what do we call the one up there? A is called parallel circuit. And in parallel circuit, we have many paths for electricity to move through. So they are not connected on one loop. Like every pulp has its own circuit, if we can say, its own circuit. If one part of this circuit breaks down, the other parts will still be working. Not like B, which represents the series circuit, where if one part breaks down, all the circuit will break down too. Okay? Do you guys get it?
Yes.
Yes. Do you have any questions?
No.
Are you sure
No.
about this?
No. Yes.
Okay. So here is showing you all the questions we were talking about. Okay.
Okay.
Here also is showing you how the parallel circuit will be brighter bulbs because energy is like more powerful here because every bulb has its own path of in the circuit. While the series circuit, because the energy of the battery is divided between two bulbs, now they are dimmer. which means less brighter. They're not the same bright as in the parallel circuit. Okay? Okay?
Okay.
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 Okay. Thank you guys for being active with me today. Okay, so here's showing you how to use the series circuit. So we can use it, for example, in lighting up things like the Christmas tree. If one bulb breaks down, the rest of the bulbs will actually turn off. But because I want now to make bigger trees, like the one in the streets, the one that is lighted up for everyone to see. Now I should use the parallel circuit because if one bulb breaks down, the tree will still light up, right?
Yes.
Everyone can
Yes.
understand this part?
Yes.
Yes.
Yes. Okay, so here is another look of electricity moving through the circuit. Can you guys see it? This is a series circuit. And this is, let me move to the next slide. This is a series circuit with two bulbs. Now, can you see how the energy first, the first bulb got all the energy from the battery? Can you see the two boxes inside? They represent the energy from the battery. Can you see? Now, when I have two bulbs, everyone will have a part of this energy, and that's why they appear dimmer, not bright enough. But in a parallel circuit, each bulb has the same amount of energy from the battery. So that's why they bright way stronger than the one in the series circuit. Okay? Do you guys get it for today?
Yes.
So that was the end of it. So you learned about the parallel circuit and the series circuit. Those are used to move the current through them. So they are used for current electricity. While static electricity doesn't need wires to move through because it doesn't move at all. It just builds up on the objects. Okay?
Okay.
Okay. So do you guys have any questions before leaving?
No,
Yes.
thank you.
Okay,
I
Rugmini.
have
Yes, Rugmini, yes. The meeting will end because we have less than a minute. I told you to send me
I
your
have
question. Can you send it to
I
me?
have the screen Miss Naha, I have the screenshot.